Good day and welcome to Big Bad Tech. I'm Instructor Jim Pytel, and today's topic of discussion is converting between engineering prefixes. Our objective is to learn to express the same number using different engineering prefixes. This lecture operates under the presumption the user is marginally skilled at writing and reading numbers in proper engineering format and can enter and interpret numbers expressed in engineering format in the TI-89 scientific calculator as illustrated in the engineering notation and engineering notation on the TI-89 lectures, both available at the Big Bad Tech channel. If you haven't watched these lectures yet, or only dimly recall their contents, please take the time to do so now. As you're no doubt aware, engineering format makes unusually large or unusually small numbers easy to write, read, and most importantly, conceptualize. The most commonly used range of engineering prefixes features the base unit, necessitating no prefix. The next largest prefix is the kilo, abbreviated small k, equivalent to 10 to the third or 1,000. The next larger prefix is the mega, abbreviated capital M, equivalent to 10 to the 6 or a million. The next larger prefix is the giga, abbreviated capital G, equivalent to 10 to the 9 or a billion. Finally, the next larger prefix is the tera, abbreviated capital T, equivalent to 10 to the 12 or a trillion. These positive powers of 10 and steps of 3 are equivalent to leftward shifts to the decimal place from the base unit. For example, the number 2,500,000 watts would be more appropriately expressed as 2.5 megawatts in proper engineering notation. If one had to enter 2.5 megawatts into the TI-89 scientific calculator, we're presented with several options. Option 1. Type 25 followed by a shit ton of zeros, 0000, and press enter. The calculator, provided it's set up to display numbers in engineering format as requested in the aforementioned lecture, immediately reformats into engineering format, expressing the coefficient, in this case 2.5, the symbol E, letting you know this is engineering format, and the power of 10 to which this is raised, in this case 6. Option 2. Type the coefficient, in this case 2.5, press EE, then tell the calculator to which power of 10 you wish to raise it to, in this case 6. Either method yields 2.5 E6, or 2.5 times 10 to the 6, or 2.5 times a million, or 2,500,000 watts, more appropriately expresses 2.5 megawatts in the proper engineering format. By the way, this lecture is meant to be a follow-along exercise. And if you don't have a Texas Instruments TI-89 Titanium Edition scientific graphing calculator in your hot little hands right now, you need to pause the lecture and go get yourself one ASAP. Returning to the base unit, one can also use engineering prefixes to represent extremely small numbers. The next smaller prefix is the milli, abbreviated small m, equivalent to 10 to the negative third or 0.001. The next smaller prefix is the micro, abbreviated as a funny looking U with a long tail, equivalent to 10 to the negative 6 or 1 millionth. The next smaller prefix is the nano, abbreviated small n, equivalent to 10 to the negative 9th or 1 billionth. Finally, the next smaller prefix is the pico, abbreviated small p, equivalent to 10 to the negative 12th or 1 trillionth. These negative powers of 10 and steps of 3 are associated with rightward shifts to the decimal place from the base unit. For example, consider the number 0.000000015 farads. Shifting the decimal place 9 spaces right, this would be more appropriately expressed as 15 nanofarads in proper engineering format. If one had to enter 15 nanofarads into the TI-89 scientific calculator, we're again presented with several options. Option 1, the hard way. Type 0.000000015 and press enter. The calculator, provided it's set up to display numbers in engineering format, as requested in the aforementioned lecture, immediately reformats into engineering format, expressing the coefficient, in this case 15, the symbol E, letting you know this is engineering format, and the power of 10 to which it is raised, in this case, negative 9. Option 2, the easy way. Type the coefficient, in this case 15, press EE, then tell the calculator to which power of 10 you wish to raise it to, in this case, negative 9. Note that the negation key at the bottom is different than the subtraction operation key on the right-hand side. To negate a number, simply press the negative sign and the number of interest. Either method yields 15e negative 9, or 15 times 10 to the negative 9th, or 15 times a billionth, or 0.000000015, more appropriately expresses 15 nanofarads in proper engineering format. This should be a review of the aforementioned lectures. Today's task is to learn how to convert between different engineering prefixes. Thus far, we've kind of limited ourselves to discussing number expressed in either the base unit or in proper engineering format, where proper engineering format uses a coefficient equal to or greater than 1 and less than 1,000 times the power of 10, where that power of 10 is expressed using a prefix. While the base units and proper engineering format are the most common means of expression, there are occasions in which numbers must be expressed using other prefixes. For example, you might find equipment that presents a fixed range of measurements only using a specific prefix. Any measurement taken by this equipment is always presented using that prefix and that prefix alone, and one must take steps to convert the measured value to proper engineering format or some other usable prefix. Key to conversion is your understanding of this simple concept. Equivalency must be maintained. They're the same numbers. 2,500,000 watts is equal to 2.5 megawatts, and 0.000000015 farads is equal to 15 nanofarads. The base units in proper engineering format are just different means of expressing the same numbers, one notably unwieldy and the other more compact and efficient. To express numbers using different engineering prefixes, one must maintain this equivalency. A fitting analogy might be used to illustrate this fact, that of money. Let's say your lazy lab partner owes you $10. On the rare chance they repay you, you might expect them to give you a single $10 bill, where that debt has been repaid using the most compact and efficient means available, i.e. a single bill. Other increasingly awkward options exist. They might repay the debt using two $5 bills. Just as easily, they could repay the debt with 10 $1 bills or a weighty sack of 1,000 dirty pennies. Get it? It's still $10, but it takes a greater quantity of smaller denomination currency to yield the desired result. If we follow this analogy in the other direction, they could also just rip a $100 bill into 10 equal pieces and give you one of them, i.e. give you a smaller quantity of a greater denomination currency to yield the same result. This, by the way, is not a recommended practice. Similar things can be said about engineering prefixes, albeit in a much simpler fashion. Every greater prefix is 1,000 times greater than the one below it. Just as easily said, every lower prefix is 1,000 times less than the one above it. Two prefixes away is 1,000 times 1,000 or 1,000,000 times different, and so on. For example, it takes 1,000 base units. Let's say we're talking about power measurements units watts to make a single kilowatt. Just as easily, it takes 1,000 kilowatts to make a single megawatt. So if 1 kilowatt is 1,000 watts and 1 megawatt is 1,000 kilowatts, it stands to conjecture that 1 megawatt is 1,000 times 1,000 watts, or 1,000,000 watts, as we might expect. This conversion also works in reverse. 1 watt is also equal to 1,000 milliwatts. 1 milliwatt is equal to 1,000 nanowatts. So it would take 1,000 times 1,000, or 1,000,000 nanowatts to equal 1 watt. Long story short, there's a fixed symmetry designed into engineering prefixes that makes it extremely simple to convert from one prefix to the next. As we learned in previous lectures, a simple way of thinking about engineering notation is moving the decimal point left or right in 3-step increments. Think of each engineering prefix as occupying a vertical column 3 spaces wide. Consider the quantity 2,500,000 watts. Expressed in the base unit of watts, 2,500,000 watts has a decimal place here. Take the decimal place intended for the base unit and move it 6 places to the left, or positive 6 places. Tell everyone you move the decimal point 6 places left by using a mega prefix, 2.5 megawatts. What if we want to convert the same quantity, 2,500,000 watts, not to megawatts, but rather kilowatts? A kilowatt is 1,000 times smaller than a megawatt, so one might expect it would take 1,000 times more kilowatts to maintain equivalency. Simple. Don't move the decimal places 6 places left into the megawatt column. Just move it 3 places to the left into the kilowatt column. 2,500,000 watts, expressed in units of kilowatts, is 2,500 kilowatts. What if we wanted to convert this same quantity, 2,500,000 watts, not to megawatts nor kilowatts, but rather gigawatts? A gigawatt is 1,000 times larger than a megawatt, so we might expect to take 1,000 times less gigawatts to maintain equivalency. As previously, don't move the decimal places 6 places left into the megawatt column. Move it 9 places left into the gigawatt column. 2,500,000 watts, expressed in units of gigawatts, is 0.0025 gigawatts. Get it? All these numbers are the same. They're just being expressed using prefixes with different currency values. 0.0025 gigawatts is equivalent to 2.5 megawatts, which is equivalent to 2,500 kilowatts, which is equivalent to 2,500,000 watts. Notice how it takes a smaller quantity of gigawatts, i.e. the high-value currency, to express the same value, whereas it takes a larger quantity of the base units, watts, i.e. the low-value currency, to express the same value. One could perform this same technique over and over to truly idiotic dimensions of granularity. A shift of the decimal place 3 steps left shows that 2,500,000 watts in the base unit is also equivalent to 2,500,000,000 milliwatts. Similarly, a shift of the decimal point 6 steps right shows 2,500,000 watts in the base unit is also equivalent to 2,500,000,000,000 microwatts. In each scenario, it takes less of the large currency prefixes and more of the small currency prefixes to express the same value. How much less or more? 1,000 times less every jump. That's the beautiful symmetry of engineering prefixes. There's a predictable pattern, unlike some measurement systems using archaic equivalencies like feet to miles, cubic inches to gallons, or barrels to hogsheads. If you use this overlay method, every move to a different prefix is a shift left or right of 3 spaces, equivalent to 1,000 times jump. All you got to do is lay out the number properly and shift at will into any desired prefix. It may seem awkward at first, but trust me, with some time and practice, believe me, you'll get plenty of practice, this technique will become easier and easier and more fluid. Let's try another illustrated example.